All right, so today we're working on section 6.7, which is solving by using or solving radical equations. Okay. Now these are the basic ones, like it says, so it's not the ones that are like a little bit more complicated, but they might look complicated as we move on, but they're not supposed to be. If we get into the more complicated ones, which I don't remember, if we do, you'll be able to tell those are a little bit tougher to do. Um, Okay, so a couple things that I had up there for you guys to remember. First off, make sure that you remember that in order to get rid of a square root, you need to square it, right? So I gave you two little examples of that, right? So if we put the square root of x, if I square the square root of x, I just get x. I have the square root of 2 minus y. If I square the whole thing, I just get 2 minus y. So the way you make the square root disappear is you square it, okay? And since we're going to be solving equations, if you square the square root, you're going to have to square the other side of the equation as well. So you'll see what I'm talking about right now. Extraneous solutions, they're going to be asking us to check to see if your solutions work. So they're going to tell you, like, make sure that you identify the extraneous solutions if you have any. Extraneous solutions are answers that we find that don't actually work for the problem. So what we're going to have to do is check our answer. That's basically what they want us to do. Check our answer and see if it works or if it doesn't work. Because if it doesn't work, we're going to say it has no solutions. If it does work, then our answer will be the correct answer. All right, so we're going to be checking for extraneous solutions. So here we go. We have 5 examples to do. There's only one main instruction, which is to solve and check for extraneous solutions. I'll give you guys a minute to write that out, but solving, and then we're going to check to make sure that whatever answer we get makes sense. So for example 1, we have 8 is equal to the square root of 4p. Now I do have to solve for the variable p. So right now the variable p is stuck inside of the square root. So I want to get it out. Okay, I want to get it out of the square root. So in order to get it out of the square root, I'm going to square both sides. Okay, so I'm going to square the left side, and I'm going to square the right side. All right, now I know that 8 squared is 64. And then the square root of 4p quantity squared, so remember, squaring a square root makes it disappear. This becomes 4p. So what do I have to do to solve for p? Divide by 4, right? Remember, it's 4 times p, not 4 plus p. So 4 times p, that means I got to divide. So I'll divide both sides by 4. And that's going to give me my answer of 16. Now I got to check it. Make sure it works. Okay? So let me check this thing. I'm going to put a 16 where p is of the original problem. So 8 is equal to the square root of 4 times 16. So 8 is the square root of 64. Well, that's true. So that checks out. So the answer works. Okay? So 16 equal to p is the correct answer. It does work, so I don't have to like cross it out. So we're done. So again, these are basic solving for radicals. Okay, so they do get a little bit more involved in this, but I mean this is the main idea: square both sides, and then solve. Sometimes you might have to fix it a little bit, but for the most part, you're squaring both sides, and then you're solving. Any questions on this one? Again, the main thing is squaring, right? So here's another one. Because there are some that have fractions inside, which is okay. It's not a big deal. But example number 2 is the square root of p over 2, and that's equal to 5. So I'm going to do the same thing I did in the other problem, okay? I have the square root all by itself on the left side, a number on the right side. Let me just square both sides. I'm going to square the left side. I'm going to square the right side. So if I square a square root, it goes away. So P over 2 equal to 25. So to solve for P, what do I do to both sides? I gotta multiply, right? So I'm gonna multiply by 2. Okay? So P is equal to 50. Alright? So let me go ahead and plug that in just to make sure. Do the check step here. Square root of 50 over 2 is equal to 25. And 50 divided by 2, that's 25. I'm sorry, not 25. What am I saying? 5. In my head, I did a quick division. The square root of 50 over 2 is equal to 5. The square root of 50 over 2, that's just 25. And the square root of 25 is 5, so that checks out. So that means that P equal to 50 is a correct answer. Extraneous solutions don't happen a lot, so don't be surprised if maybe you don't find any. But you do have to check for them, because every once in a while you find an answer, you plug it in, and inside your square root, it's a negative number. And we can't have negatives inside square roots. If we do, they're called imaginary solutions. So in other words, they don't have real solutions. So you do have to check them, even though they don't happen often. All right? So we have 3 more to go. We're going to start to make it a little bit more interesting. Not that it's more difficult to do this one. We're still going to follow the same pattern we've been doing. We see a square root equal to something. We're going to take squares on both sides. So we're still going to do the same thing, just that now it's going to take us a couple more steps to solve. So example number 3 says the square root of 9a plus 10 is equal to 8. So if I square both sides, so I can get a by itself, I need to get it out of that square root. So I'm going to square it so that we can move it out. Okay? So the square root of 9a plus 10 squared is just 9a plus 10. And 8 squared is 64. Now we'll go ahead and start solving. So to get a by itself, I'm going to get rid of that plus 10 first. So we'll subtract 10 on both sides. That gives me 54 equal to 9a. And if I divide both sides by 9, what do I get? Say it louder. 6. Yeah. I get a equal to 6. So that's my answer. Let's just check it. We got to make sure we check it. I used to hate these problems that made me check all the time. But if one of the answers don't work, then I have to make sure I know, right? So you kind of have to check it. So the square root of 9 times 6 plus 10 is equal to 8. Well, 9 times 6 is 54 plus 10. That's equal to 8. So that's the square root of 64, which is equal to 8. So that works. So that means a equal to 6 is a valid answer. So I'm going to go ahead and put a box around that one. Now the next example will look a little bit more complicated than this. Like I said, they vary. So as you start in the very beginning of your homework, they start looking like the first ones we did. As we move on, they start to get more and more complicated. But even though they look more complicated, it does not mean that they're harder to do. The process stays the same. It doesn't matter that there's negatives all over the place and stuff like that. Notice they're both inside of square roots. So the main thing is let's get rid of the square roots. Okay? And to get rid of square roots, we square. Right? So that's basically all we're doing is squaring to start this off, with the exception of example 5, because that one starts off a little different. But we will eventually square on that one. So I'm going to go ahead and square both sides. So I'm left with negative 7 minus x equals negative 16 minus 2x. I usually like to combine my variables first, and I like to take the smallest variable and move it over to where the bigger one is. So negative 2x is smaller than negative 1x. So I'm going to add 2x to both sides. It doesn't matter which one you move, just so you know. It's not like you're going to get it wrong. I just like to try to keep my numbers positive as much as possible. So by doing that, I'll make it a positive variable right now. So this becomes negative 7 plus x equals negative 16. Okay? And now I'm going to add 7 to both sides. So if I add 7, I get x equal to negative 9. So I have to check it. Let's do my check step right here. So x is negative 9. I'm going to plug it in, and I'm going to put in a parenthesis because there's signs and stuff all over the place. So here we go. Square root of negative 7 minus negative 9 is equal to square root of negative 16 minus 2 times negative 9. All right, on the left side, I have negative 7 minus a negative 9. That's actually a plus 9. So negative 7 plus 9. On the right side, I have negative 16. Negative 2 times negative 9 is positive 18. Negative 7 plus 9 is 2, so radical 2. And negative 16 plus 18 is 2 as well. So radical 2 equal to radical 2, that looks right to me, right? The same thing. So that means that x equal to negative 9 works. Okay? So as long as I get the same answer on both sides, I should be good. Now if you're wondering, well, wait a minute. On the previous check steps, you never showed me that they were both identical. The reason why I didn't is because I figured you guys know that the square root of 64 is 8. But if you want to go one extra step, you can go 8 equals 8, right? And for the previous one, you could have put 5 equals 5, right? So that works out. And for this one, 8 equals 8. You could have, but if you already know it's true, then you don't have to write the extra step, right? It works. So you didn't have to go all the way down to the bottom. Whereas here, it's not that I'm not going to the end. It obviously says radical 2 equals radical 2. So, I mean, I could square both sides, make it say 2 equals 2, but for what? I already know that that's equal, right? I don't have to go any further. So before we get to the last one, any questions? 1 through 4? Does it seem pretty simple, right? I mean, it's not as easy as yesterday's, I think, but the idea is just square, okay? Square, and that'll get you to the point that you want it to get you to. So this one is a little different. I think it's prepping us for the more complicated problems, even though this one isn't that complicated, but I think it's trying to prep us to get there. Sometimes you have to fix the equation before you can actually square it, okay? So this problem is not from your homework. The other 4 are, but this one is not because there's only one of these on your homework, so I want to let you guys do that one. But it's very similar to this, okay? And it's not ready for me to just square everything, okay? I got to try to get a square root all by itself. And if I can get the square root all by itself, then I can square both sides. So what I'm going to do first is let me subtract 10 to the right side. So that's going to give me the square root of 2x plus 100 is equal to 10. And at this point, I'll square both sides. Because now it's kind of just like one term on the left side, one term on the right side. Okay? The more complicated problems, sometimes you have 2 terms. And that's never a nice thing to see. So that's why they call those more advanced. Okay, these are the basic ones. So we're going to square both sides. So what do I get here? 2x plus 100 equals to, what's 10 squared? 100. Okay, I'll subtract 100 from both sides. So I get 2x equals to 0. And if I divide both sides by 2, x is equal to 0. All right, so there's my answer. I just got to check to make sure it works. So here we go. 10 plus the square root of 2 times 0 plus 100 is equal to 20. Well, 2 times 0 is 0, and 0 plus 100 is 100. So it's 10 plus the square root of 100 is equal to 20. The square root of 100 is 10, and 10 plus 10 is 20. So there you go. It works. Like I said, extraneous solutions don't pop up very often, so don't get frustrated if none of these happen. Okay? They do tend to pop up a little bit more when we have more complicated problems, the advanced problems. Okay? Sometimes you get many of those, in that because sometimes we're solving like squares and stuff inside, so they have two answers instead of just one. So if it doesn't show up in this one, it's okay. Okay? Usually the more advanced problems we'll have. So I'll stop right there. I'll give you guys your homework right now so you can hopefully try to get it done. It's not too long.